Hey, sixth graders, this is Mrs. Newsome. It's been a long time since I made you a math video, but today I wanted you to tackle lesson 411 alongside with me here in the video after your retake. Today is kind of like review of what we've done the last couple days with inequalities. And so I thought this would be something that you could handle on your own or alongside me in the video. So in your math journal right now, I am on page 200. Okay, so you can pause the video, turn to page 200, and then work alongside with me. So the math message is asking you, which of the following situations could you model with 8 is greater than x? You and I talked already that I like it best when these are flipped around, and so x is less than 8. So I like to think about it always with the variable first. So x is less than 8. So let's think about which of these could work for that. A number substituted for x is less than 8. Well, that's exactly what it says, right? So that one works. Let's see, Sarah is 8 and her older sister is x. Nah, it would have to be younger sister, right? Because x is less than 8, not older. Not that one. Let's check C. There are fewer than 8 people, and x represents the number. That makes sense, right? X is less than 8, so there's fewer than 8 people. I like that one. And then let's see if they graph this correctly. So we have an open circle, I think at 8, 6, 7, 8. And we know open circle means that it can't be equal to, so that looks right. And less than goes that direction. So yeah, that looks right. So A, C, and D all are expressions there and stories, situations that can match x is less than 8. Okay, so just a little warm up. The rest of today, we are look at this, inequalities in a real world situation. So we're going to be writing inequalities, graphing inequalities, and trying to think about these in a real world situation. Let's look at number 2. Alligator adventures take people out on a boat to see alligators in the wild. The boat can hold a maximum of 10 customers, right? So that's the most people they can fit on that boat is 10. So, and it says the number of people in the boat varies each trip. Okay. So define your variable. And remember, your variable is like, what are you counting? So I'm counting customers. So we're going to let C equal customers, right? So that's what I'm counting. Then it says, explain which numbers do not belong in the solution set. So this is the do not. So if I'm thinking about this boat, it could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Could have up to 10 people. But I couldn't have, so I'm going to say not bigger than 10. That wouldn't work, right? Could it have negative numbers? Can we have negative customers? No. So I'm going to say no negatives. Okay. And so that's kind of like our solution set. It can't be bigger than 10 and there's no negatives. So that means that we've got to write number models to describe this situation, right? So I'm going to say that C has to be greater than 0 because that's going to save me no negatives. And I'm going to say C has to be less than 10. Okay, so I kind of have this range. It's got to be between 0 and 10, right? It can't be bigger because it says the boat won't hold it. It can't be less than because that doesn't even make sense. Remember, this is a real world situation. So C is greater than 0 and less than 10. Now I need to think about the equal to part, right? Can it be 0? Can they take 0 people on a boat? Sure. So that's going to be greater than or equal to. Can they have 10 people on the boat? It says yes, maximum of 10. So that one should also be less than or equal to. So you've got to kind of think about those equal to parts. All right, so now let's graph it. Since these are both equal to, they're going to be solid circles at 0 and 10. And my line is going to connect them up in the middle, right? So it can be anywhere between 0 and 10. And that'll be how many people can ride in that boat. Okay, does that make sense how we're doing this? All of these situations are going to have some limits, and that's kind of what these two things are. The lower limit is 0, the higher limit is 10, and so we have to write two inequalities to show where those fit. Let's take a look at number 3. The boat operates when the air temperature is at least 55 degrees Fahrenheit. Okay, but the temperature varies. Okay, so if it's 55 or higher, they're going to take people out on this boat trip. Okay, so let's define our variable. So what are we counting? Temperature. So let's do T equals temperature. Explain which numbers do not belong. Well, it says it has to be at least 55. So not smaller than 55. Now, this next part, like, how high can it go? Do you think they'll take people out if there's 100 temp degrees? How about 150 degrees? Well, that's not even realistic, right? Like, they probably have an upper limit of somewhere. Would we like to set an upper limit for their temperature? You think? How when they would take that boat out? How about Florida? Do you think it ever gets above 110? I think 110 would be really hot in Florida. It's so humid. How about we say 110? So not higher than 110. And I'm just making that up, right? Like doesn't say that anywhere. I'm just setting myself a limit. Most of the time it's going to give you limits like it did in number 2, but here I'm just setting myself a limit. I am misspelling stuff all over here too, all over you guys. All right. So now let's record our inequalities. So we know it's got to be not smaller than 55, but our temperature has to be greater than or equal to, right? 55 degrees. And I want the temperature to be less than 110. And I'm going to leave that less than. I don't even want to go if it's 110. Okay? If you want to make that a little different, you can. But I'm going to leave it there. That to me seems reasonable. So what that means is at 55, I'm going to put a closed circle. And at 110, I'm going to do an open circle. And I'm going to connect those up. So any temperature in between there is going to be when they're going to run their boat ride, between 55 and 110. Okay, I think that's pretty reasonable. Do you see how this is working? We're defining a variable. We're telling when won't work. Then we're using some inequalities to give the limits. And then we're graphing it. All right, we have 4 and 5 left. Let's take a look at 4. So 4 says alligator adventures guarantees that you will see more than 2 alligators or you get your money back. And the number of alligator varies on each trip. Okay, so we're counting alligators, right? So that's my variable. A equals alligators. I think I misspelled it again. Is that good? No, I didn't. Okay. And what are the numbers not in the solution set? So they're guaranteeing we're going to see more than 2. So not 2, right? They're saying more than 2. Not less than 2. But I think it could be anything else, right? Like, I don't think we'll see 30 alligators, but maybe we will. So why don't we leave that one open on one end? So it's just going to be more than 2. So alligators are going to be greater than 2. And it says more than, so it's not equal to. So let's find a 2. It's going to be an open circle. 0, 1, 2. And then they say we're going to see more than that. So my line's going to the right because it's going to be bigger. Does that make sense? We're going to see greater than 2 alligators. All right. Let's look at number 5. This is kind of the last one we're going to tackle here, but why don't you pause the video and try this one on your own and then turn it back on and see if you got it right. It's kind of a good little test. I'm going to go ahead and start because I'm not going to pause my video. This is the boat can travel 20 miles per hour at most to avoid scaring the alligators. So 20 miles is like the most it can go. We're talking speed, right? So I'm going to say S is going to be my speed. What is it not? So it's not bigger than 20. And it's going to be not 0, right? Because it's not even going to be moving if it's then. And I'm going to say not less than 0. So it's got to be bigger than 0 and less than 20, right? between 0 and 20. That makes sense? I think so. So I'm going to say the speed has to be greater than 0, or otherwise it's not even moving. And then I'm going to say the speed has to be less than or equal to 20, because it said at most, so that means it's okay at 20. So this is going to be open circle at 0, closed circle at 20, and we join those two up. And that's what that looks like. Okay. So this last piece, I am going to kind of let you think about what are some differences in how your graphs are constructed. If you take a look, I don't know if I can get them. Let's see if I can get them all in there. Yeah. So what are some differences? And mine are all in blue, so they kind of stick out. Like I noticed some of them have 2 closed circles. Some of them has closed and open. Some of them only stops in one direction and goes forever. So there's some differences there. Some of them are a wider range. Some of them have an infinite range. Some of them have maybe a small range. And actually, 0 to 10 is smaller than 0 to 20, right? It just looks bigger because of the way they have their number line. So think about that a little bit. You do not have to worry about the try this. I'm not going to ask you to do that with me today. And that's all. So if you work those 2 pages, take some pictures of them with your camera, and then submit them in Canvas, you will have finished today's inequalities in the real world.